Hello everyone, my name is Cyrus, and today I'll be presenting my project titled Fault Tolerant Web Infrastructure, or also a RAID Array plus Web Server. This project focuses on building a resilient, self-healing web server using a Raspberry Pi, Apache, WordPress, and a RAID 1 mirrored storage system. The main goal was not only to deploy a functional website, but to ensure that the website stays online even if a storage drive fails, something that is extremely important in real-world cybersecurity and IT environments. Over the next several minutes, I'll walk you through the motivation, the architecture, implementation, and finally, the results of a real time failure demonstration that I conducted myself, showing that the system continues to run even under hardware failure. The executive summary. The overall objective was to deploy a production ready web server with true hardware redundancy. To accomplish this, I used a Raspberry Pi, Linux, configured with RID1 using the MDADM software tool. The key outcome of the project was achieving high availability, often abbreviated as HA. High availability means system continues to function even when individual components fail. So the problem statement. The core issue of this project solves the core issue that the project solves is downtime. Most Raspberry Pi based servers rely on a single SD card. This SD card becomes a single point of failure. If it corrupts, even slightly, the web server immediately goes offline and data is often lost completely. Similarly, without redundancy, any corruption inside the web directory instantly shuts down the site. From a cybersecurity perspective, this directly connects to the CIA triad confidentiality, integrity, and availability. This project focuses on the availability pillar, which ensures services remain up and accessible when they're needed. The business case. In designing this system, I wanted something that is not only functional but also scalable and realistic for real world use. First, storage redundancy ensures the system remains operational even when a drive fails. Second, RAID 1 provides strong performance, especially with read options, because data can be fetched from either drive. Third, it is extremely cost effective. Software rate is free and the hardware cost is minimal. Fourth, the deployment process is very straightforward. WordPress is easy to install and manage. Now, talking about the system architecture, at the center of the system was the Raspberry Pi, which acted as the controller and main processing unit. Two USB drives plug into the Pi and form the RAID1 mirrored array. Networking is handled through an Ethernet or Wi-Fi depending on the situation. Management is primarily done through SSH, which allows secure remote access. Now, the tech stack. The tech stack is a collection of tools and services that work together to run the web server. I used an operating system that's Raspberry Pi based on Debian. Apache 2 acts as the main HTTP web server. MariaDB serves as the SQL database required for WordPress to function. PHP handles the dynamic rendering of WordPress pages. And finally, MDADM manages the RAID 1 array. This tool allows Linux to combine multiple physical drives into one logical storage device. Apache introduction. So Apache is the world's most widely used web server, powering millions of websites. It handles incoming HTTP requests and returns the appropriate web pages to users. In this project, Apache forms the foundation of the entire web stack. So these are a few of the commands that are used for Apache installation, also MySQL and MariaDB installation. Now, the WordPress configuration. To configure WordPress, I downloaded the installation package, created a database and user in MariaDB, assigned appropriate ownership to the WordPress directory, and edited the wp-config.php file. This completed the basic setup of the WordPress application. Now, this page shows the default page from Apache 2 that shows that uh, were able to we were able to configure the server correctly. Now, talking about the RAID theory, before implementing RAID, it's important to understand how RAID 1 works. RAID 1 mirrors data across two drives. Whatever is written to one drive is written technically to the second drive. If one drive fails, the other continues to operate, meaning no downtime and no data loss. This is why RAID 1 is commonly used in production systems where reliability is critical. Now I'll explain this RAID diagram. This diagram shows how the Raspberry Pi interacts with both drives. Even though there are two physical drives, the operating system views the RAID array as a single virtual device. Now these are a few of the commands, RAID commands that I used to create the RAID array. The important one is mdadm dash dash create, which initializes the RAID 1 device. And then the second one is the cat slash proc slash mdstart command that checks the RAID status and shows whether the array is healthy or degraded. So over here, these were a few of the screenshots that I took while completing the process. And now we talk about file system setup. Next, I formatted the RAID array to the ext4 file system and mounted it at the mnt RAID 1. This step prepares the RAID to store website files. So as you can see over here, this is one of the screenshots that shows the process. This is the second one. And now we talk about the fstab configuration. These were a few of the commands that I used to ensure the RAID mounts automatically on boot. I added an entry to the etc fstab file using the RAID device's UUID. This makes the system consistent and reliable after every reboot. Fstab screenshot is yeah, this is the fstab screenshot that we can see. And now we started with the migration plan. So the next step was to migrate the WordPress files from the SD card to the RAID array. This prevents data loss if the SD card becomes corrupted. Now, these were a few of the screenshots that I took while the process was happening. Now, uh, talking about migration execution, these were the commands that I used for the migration execution. And this shows that we have the HTML file in the mntraid1. Now over here we can see that the WordPress process is happening, and we are able to host the WordPress on our RAID array. Now this shows the migration proof. You can see that it's active and running. So these screenshots show the WordPress files inside mnt RAID1 HTML and the website being successfully served from the RAID1 array. Then we type in localhost on our web browser and we see this page, which verifies that the WordPress is being hosted from the RAID 1. This is the second page. Then I conducted a disaster simulation where to test the reliability of the system. When one drive failed, the RAID status changed from UU to U dash, meaning the array was degraded. And these were a few of the commands that I used. So over here we can see that we have a degraded system with a dash U, and to recover that it would take around 426.3 minutes. So this was the screenshot that I took in the degraded state with the cat proc md start command. But since we were successfully able to host the website on our RAID 1 array, we type in localhost again even after one of the drives doesn't work, and we see this page that RAID is degraded but site still works. So this was the page that I was able to view even after one of the drives failed, but the other kept on hosting the web page. So now talking about the restoration process, I then re-added the failed drive using the mdadm dash dash add command. Once added, the array automatically rebuilt itself, and the process was still happening. This shows the healthy state where we can see that we have the UU back. So the lessons I learned was this project helped deepen my understanding of Linux administration, block devices, file systems, RAID logic, and the importance of availability in cybersecurity. Talking about the business impact, with less than $50 of hardware, I was able to build a system that demonstrates genuine fault tolerance. This type of architecture is scalable, secure, and provides strong uptime guarantees. Thank you for watching the video.